stream.
It actually seems to be live already.
Yes, yeah. We started streaming automatically. All right, let me just start the Discord event then, and then we'll give people a few minutes to join. Hey, everyone. Nazar, are the comments distracting on the screen? Because I can hide them during the workshop, or is that okay?
It's fine for me because I'll be clicking in the VM. It's more of the question for the audience, how much it will be like overlapping the content for them, but we'll see.
Okay. Right. We'll wait for another minute, and we'll get started. Nazar, do you want to test the screen sharing?
Yes, that's a good idea. Sometimes works and sometimes it's more tricky.
Are you going to be using the Linux VM today?
Yes, I'm just feeling more comfortable with that, like shortcuts and everything.
Yeah, of course.
I think I should be able to also maximize the screen sharing. Yeah.
Yeah, I'm probably going to hide the chat.
Yeah.
At least during the stream.
I think it's way more readable this time.
Yes, I think so too.
Yeah, it looks better to me.
All right, I think we should get started. Hey everyone, and thank you so much for joining us for the new edition of the Space Acres Workshop as a part of Developer Office Hours and Hacker Month. Yeah, we're really excited to have all of you here, and this time is going to be the last event in our series of events that we hosted throughout the month. And yeah, Nazar, thank you so much for spending a lot of time with us during this month. We really appreciate all the workshops, and hoping that it's not the last time we see you around on Developer Office Hours. And without further ado, yes, thank you. And without further ado, let's get started with the workshop.
Hey guys, so we had two workshops before. Once we've set up environment in Linux and did a small thing with Space Acres, and the second time we did kind of the same story but in Windows. Again, started from scratch and did a small feature. this time I want to show you a little bit more of Subspace other things, because previously we were not really focusing on Subspace as such, but SpaceAcres does wrap Subspace underlying components and runs them basically in the same way as you would run CLI, just in a graphical interface. So in terms of performance, there are some questions in Discord. Performance is about the same. There are some slight efficiency improvements from the fact that it's running in the same process. We can do better caching and things like that. But otherwise, it's pretty much the same. So I want to give you a small walkthrough of the components that we are touching in SpaceAcres that are coming from Subspace monorepository. And then we'll try to do a small thing, which will not be able to complete fully, but at least we can get an idea of how to approach it. So as of today, in the monorepo, the way we have things structured, the bigger thing is crates, where most of the crates that are like consensus related are located. And in here, we have both libraries and binaries. So when we're talking about binaries, you will see Subspace Farmer and Subspace Node as two familiar things. And then we can start from Node. This is a regular Rust binary kind of layout. We have main RS, which is the entry point. And here we will see a main function that basically starts an application. We have some command line arguments. I think I see a spinner on YouTube. Can you still all see me? I hope you can. Okay, cool. So in here, we have basically like CLI options, all of the different commands you can run. The main thing you would run is basically run. And if you jump here, we can see that also we have some options for it. And we do a setup. And the way this particular command differs from SpaceAcres is that the Subspace Node application supports both consensus and domains. So for domains, we have some extra options that we are running, but you can basically see it in here. There is some setup for logging and for file descriptor limits and some other things. And then we basically create a consensus chain configuration with this function call. And then we create a domain chain configuration with this function call. And then we do some like logging about things. And then we basically start both of them. And the important thing here is that there is a thing, well, how to start it. I don't think we need to go into the these functions. There is a lot of boilerplate here that is quite hard to read. But we can jump into the entry point where everything is kind of started. And that is a separate crate called Subspace Service, which starts all of the consensus related components of the node. So node is like a binary, but underlying that binary, there is a subspace service, which is what Subspace SpaceAcres uses. SpaceAcres doesn't actually include Subspace Node, it uses the service. And there is a function called new partial, and then there is a new full. You basically need to call them one after another. And as the result, you will get a data structure called full node. If we jump to it, well, this is not super helpful. Let me show a different thing to you. Yeah, how do I show it to you? I think we can start with new partial. This basically prepares some of the components which are necessary in all cases and sufficient in some. So when you run a full networking stack and everything, you will need to run new full. But if, let's say, you want to generate a chain spec or something like that, like more simple stuff, then you can just get away with new partial, and then it will return you some components. The custom thing comparing to Substrate is other partial components which are subspace specific stuff we are returning. For example, our custom block import pipeline, verification for proof of time that needs to be shared between those, and some other things. And then with those, we can create a full service. And I wanted to show you what's inside of it. Let's see. There is a data structure we are returning from here. like this. So when you create a full service, you will get this data structure, and it has a few fields. The most important is the task manager. This is kind of like a container where all of the different asynchronous and synchronous stuff are contained related to Node. So basically, if you drop it, everything should stop. And the other thing is critical is a network starter, this thing. So unless you call this thing, it will not start the networking stack of Substrate. The other things are kind of sort of optional, but we return them such that we can, let's say, use client to subscribe to some blockchain notifications. We can monitor networking things, and we can use some of these components to integrate with the domains. For example, domains needs to monitor the block import, and then if something is related to domain is in that block, it can do some other things as a result of that. So things of that nature. And this is the data structure that is the only thing that's available basically to Space Acres from the outside. So all of the stuff we are dealing with are in here. And sometimes when you want to implement a feature in Space Acres, you will have to expose more things from here. It's rare, but it's sometimes necessary. So when we are going back to our Subspace node, we can see that we create this thing. It's an asynchronous thing. And then we return it to here. And then with that, we use Task Manager to spawn some additional functions. And then if we have configuration for the domain, we are again using this services task manager to add more things to it. So we are running cross-domain messaging relay, and we also run even the domain itself. So at the very bottom, we will see that we run domain as a child task of this task manager. And once everything is done, we can start the network, and then we can basically run this task manager until Control C, or like you close an application in case of Space Acres. So it will be running basically indefinitely. So this is the node side. There are many components in it. We'll probably look at some of them later, but this is kind of the general idea. We have some CLI options. We parse them. If that's a run command for the node, we start it with the service, and then we basically run that service asynchronous loop basically forever until we stop the application for some reason. The other component obviously is the farmer, and farmer is a little bit different. In the sense that this is an application and a library at the same time. So we have librs, which is showing what you can expect as a library for this crate to provide. At the same time, you also have a binary. So this is like a CLI application that also uses the library. So you will see Subspace Farmer used as a library in the binary. And here we can also trace like what you can do with the farm. For example, farm command is the default, what you would typically use. And then at the bottom in the main function, you can see that we match on that command. And if it's a farm, then we'll basically start farming. In here, there are also many different things happening. There are many different options you can provide. That's why I'm sometimes reluctant to add more options, because they can interact in different permutations with each other. And the more of them we have, the harder it is to maintain correctness, and it's just harder for people to understand what is even possible. In here, we have several different things. One of the first things is we check whether we run like temporary farmer to create a temporary directory. And after that, we will try to connect to the node. In case of the CLI, we will connect via RPC client. In Space Acres, we are still using RPC client, but if you remember Pulsar actually didn't use RPC client. It was connecting to the node directly within the process. And this is what we will use for efficiency in Space Acres later. There is an issue about that. The other thing is we create a networking identity, which is derived from the very first farm you specified. That's why if you change the order, your network identity will actually change. And then we will create farmer caches. We will create a networking stack. And then with those, we will, this is also Prometheus server for metrics. And then we will initialize a few components for the farms. And then we will start this is for all of the different CPU options, a lot of boilerplate. And then we will start the farms themselves. So for every single disk farm you specify, we will create an instance of what is called single disk farm with a whole bunch of options. And then at the very end, we basically have networking, we have a cache worker, and we have different farms. And we are basically running them concurrently with the signal, again, Control C, or if you close an app in CLI for some reason, that will exit. So this is how things are working. And basically what we're doing in Space Acres, we are running all of this at the same time. One thing I think is worth mentioning is Subspace Service has some things which are not used by Subspace Node, but are used by things like Space Acres. One of those is options that you specify for the service instantiation. If I can find it quickly, I'm not sure I will. I think there is a configuration something here. Always select open file. Yes, okay, that's easier. So we have configuration here. There is a data structure. We split them into different parts, but the thing that the service is dealing with is subspace configuration, and part of it is subspace networking. There are actually two ways to instantiate it. So in case of separate subspace node and subspace farmer, what we have is we have DSN connection from farmer and from node directly to the outside at the same time. But in case of Space Acres, this is the same DSN, so you can actually share the connection. So in the service, you have an option to either create a new connection, and you can specify some of the options that the networking stack should use. These are things like where to listen on, bootstrap nodes, things of that nature. And then for the reuse, you can actually provide the node, network node instance itself that the service will use. So with that in mind, let me jump back into Space Acres repository, and maybe you will see a little bit of like familiarity with what's happening. I think first we can jump into main and see that when we initialize everything, we will create a backend. So there is a create function here, and that function will first, in the loop, wait for configuration to happen. So if there is no configuration, it will send a message back to the UI, and UI will show you something like this. Let me start it. You will see something like this. It will give you a welcome or an error message if configuration was present but was errorless. And then you will see the configuration screen. Let me drink some water. It's hard to speak for so long. So let's close this for now. Once we have the configuration and it was successful, then we have this kind of loaded backend thing. And with that, we can run it. And let's see what the backend actually is. So let's see where you have the backend. Yeah, we have a run function. It will take loaded backend data structure, which is basically config and some additional information. Let's see. Oh, this shortcut's a little bit different on this machine. Let's see how we load the backend. In here, we basically try to load configuration, and if that was successful, we will check it, and then we will generate a chain spec, which is basically information about the chain, like the runtime that is used initially. It also contains the bootstrap nodes and things of that nature. It's coming from Subspace repository. And then we will potentially create a directory for the node if it doesn't exist yet. We will try to create a networking stack. This is what I mentioned. It is shared. So we need to create it first, and then both node and farmer component will kind of use it. And there are many different steps to it, the identities and things of that nature. And then, yeah, shortcuts are different. It's unusual. And after that, we can create a provider for pieces. This will use caches and things of that nature for both node and farmer. And then we can create a consensus node, and then we create a farmer, and then we return basically configs and node and farmer and the what else we have? Consensus node farmer and the runner, which is kind of like a worker for the networking stack. So unless you drive these three, like nothing happens yet. It's like ready, but it's not actually running yet. And once they are ready, the run function basically takes all of those components and run them. So we run networking stack in one thread. We run our farmer in another thread. And we run node again in the other thread, and then we basically race the same way. And we also have some actions that are sent for the backend from the front end that needs to be processed. So the interesting thing is, how can front end do anything with the backend? So I mentioned in the past that we have the actions, backend actions, and we have backend notifications. I can jump to notifications faster. So these are things that are sent from the backend to the front end, mostly for presentational purposes, but sometimes config is sent, so the config can be actually used for something. And there are also actions which are sent from the front end to the backend to do something. The only one I showed you last time was the new config, but you also have farm action now. And the reason for that is we have ability to pause plotting. So you can temporarily suspend plotting operations, and then you can resume them anytime, and the Boolean indicates whether it should be active or not. The way you can interact with the farmer and node, if you need to, let me jump to the run function. Well, actually, not to the run function, probably. Let's see. This notification to the front end that it's running. Yeah, so let's start with the node. Let's go to the node. The way node is created is kind of difficult and lengthy. The important thing is that we have these several components. The full node you've already seen before. We have pausing, which is a technical thing for Subspace. I wouldn't go into details. We have chain information, and we have some handlers for events. And for handlers for events are when the sync state changes and when we import new blocks. So we create this thing, and then we will have to run it at some point in the run function. And when we do that, what we'll actually do, we will take our full node, as I mentioned, and we will take some components of it, like a client. And on that client, we will subscribe to notifications about every block that's being imported. And then when we have a notification from there, we will take and we will call a handler for the event block imported with some details. And those details are block number, the reward, address balance for the farmer. This is how we actually get it. We don't have a much nicer way right now. And we can later render those notifications in the interface. But this is how we kind of capture this data. But for convenience, we have this whole consensus node data structure that we create. And that data structure, except in addition to run function, it also has other functions. And some of them are like best block number as of instantiation, but you can also subscribe to things. So on sync state change, on block imported. This is how in the backend, when we run the components in here, we can subscribe to things like sync state change, and we can send a notification, backend notification that I mentioned from the node that contains this update about sync state. So this is kind of how we are wiring. We have node, farmer, and networking kind of wrappers. And then for each of them, we have these notifications we can subscribe to before we actually start driving them to completion in this select. So I hope this is a little bit helpful. If you need to subscribe to more notifications from the node, you will probably have to add function like on sync state change, and then you will have to, on one hand, subscribe to it in the backend and send notification up to the front end. And on the other hand, you will have to do some kind of listener on something in the node that may or may not be exposed yet to actually capture that information that you are interested in, right? And let me open Space Acres repository. Okay. I don't care. At least there is not that much ads as in Edge. That was horrible. So there is an issue that we will have to resolve sooner rather than later. It's this one. Let me make it a little bit bigger. So basically, there's a problem in Space Acres right now. If you specify a size for your farm which is larger than the size, the amount of space you have on disk, it will accept it, it will restart, and it will successfully crash. It will crash because it will not be able to resize this farm up to the size that you are actually requesting. And the other kind of similar edge case is, what if there is a disk that you want to use fully? How do you guess how much space you actually want? You actually can specify. With CLI, you can kind of try to run it 10 times, and at some point it will fail, so you know how to dial it back, and then you have the size. But ideally, it would be like a checkbox in the UI: use the full drive, I don't care how much space is left. And this feature kind of covers both. So with our kind of notion of the different components and how things are working, let's try to kind of reproduce the problem first, and then we will try to address it quickly, and hopefully we'll make a little bit of progress. So let me run the thing again. Okay, so I have created a disk. I don't think I mounted it yet. Okay, let's mount it. What if I open it again? Can I see it? Okay, so let's create a node directory. And then for reward address, I will do the same hack I did before. I'll just cannibalize this ls address and just paste it in here. And then for the farmer, I will use farm 0, let's say. The size. So let's go to disks. And in disks, you know what? Let me move the node to a different disk so it doesn't crash accidentally. That will be more productive, I think. Okay, let's create a folder node. And let's see. So we have a disk, 54 gigabytes, something like that, 53 free. Let's just give it 100. Oops, 100 gigabytes. And we will not do anything else. We can just click start so we can get an error, because the space we request for the farmer is way too large for the disk we have in practice. Right. Can't pre-allocate plot file, probably not enough space on disk, not super helpful, or like not super friendly, but at least it points out to the issue you have. And right now, the only way to fix it is, well, there is no config. So basically, you need to go to here. You need to show hidden folders, config, space acres, and then you will need to edit this config and change this 100 gigabytes to something smaller. But let's say we want to handle it more nicely. So the place where it actually fails, I'm not sure we can actually find it here. I think we might be able to. So let's select this piece of text and search. Oh, we can actually find the place. So, okay. Let's see. So we have a farm that we want to create, and there is a feature that we are running. And Let's see. I think I closed it, right? Yeah. Can prelocate. So the way to approach this problem is we basically want to distinguish and intercept the error which is related to the farm size. And if that is the actual reason we failed, we would want to instead try and dial it down, right? Let's say we want to decrease it 1 gigabyte at a time in the very simplest case until we can actually succeed. If you know that's the reason. Oh, there is a black screen. Can you still? Okay, I hope you can see it. So let's go into the actual single disk farm error. And we can see can't pre-allocate, which one it was? Can't pre-allocate plot file. So for simplicity, let's just handle this one error in the farmer. Yeah, I think we need to handle more errors in here. So we are matching already. Let's say we want to match on single disk farm. This one, I'm not sure how it looks like. It's just an error. For simplicity for the live stream, I'll not go into details, checking why exactly it failed and things of that nature. But let's assume that when this happens, it happens because you don't have enough space, okay? So essentially what we want to do in that particular case, we would want to retry this operation. We want to create a single farm again, but instead of allocated space that we have in the configuration, we want to make it a little bit smaller, okay? And let's see about options. This is something we'll need to recreate again and again. All right, we can do that. So, okay, how do we approach this? Let's see. We want to get a farm in the end. So let's make a loop. And we will basically run it in a loop until we succeed. And in case we succeed, we will break it with our farm. This is something you can do in Rust. You can run a loop and then you can break with a particular value. I think there is a typo somewhere. Right. Let's see. Now it should be correct. And then let's say to do, and let's try to compile it to make sure we are cloning all of the components or all of the arguments we need to clone, because previously we were using them once. Now we will use them potentially many, many times in a loop. I think IDE should be able to help me, but it's not cooperating that much. So cargo clippy, let's do like this. It'll take a while. So I know that the info will probably need to be cloned. Farmer app info clone. And there will probably be many other things. Yeah, hopefully it doesn't take too long. Yeah, I see some questions in the chat about SSDs of different kinds. But this call is more about development rather than end user experience. So probably leave it to other team members to reply. Yeah, runtime is a big part of the compilation. We will actually get rid of it. There is a way to not actually compile it, just takes time to create the fake runtime, so to speak. Because in recent Substrate versions, you don't actually deal with the native runtime. You only have WASM, so it doesn't really matter what native runtime is, at least for the node, the way we run it in Spaceacres. So you kind of can give it an instance which has all of the right traits implemented, but they're actually like dummy traits, not doing anything, and it still will be fine. Yeah, I should have done this earlier so we don't have to wait so much.
I have a dev-related question, Nazar, while we're waiting.
Sure.
So did you just say that we can, you can in Rust, you can set a loop which breaks on a value? Do you mind just explaining that? I've not come across that before.
Yeah. So in many programming languages, you have things like while and for each sometimes and other loops. In Rust, you have a loop, which is basically equivalent more or less to while true. So basically run it forever. But then these all of these loops in Rust are actually expressions. What it means is when you have a loop, which is written like this, which is basically runs forever, it can return a value. Okay. So in this particular case, if you run it, it will be exclamation mark. So it's never type. It basically means that it will never ever exit. This is why it's grayed out. Like the IDE knows it will not be able to reach it. However, if you use break command and like instruction, and yeah, in this case you break with something, let's make it explicit like this, then that will be the return value of this expression. So what we'll do here, we will run it over and over and over again until we actually succeed with break. There is another way to exit from here. We have an error, so we can return from the whole function. But like to stop this loop from looping, we need to break it with a value, and that value will be our farm that we are interested in. This is how we will make as many attempts as necessary. Make sense?
Yeah, thank you. So it's like a function with a loop inside that will return the expected value. That's
Yes.
That's very interesting. I've not seen that control structure
Yeah.
before. Interesting. Thank you.
Okay, so okay, so it's just a warning. Let me run all targets just to make sure we didn't miss anything. But it doesn't actually complain all that much. It just says that it doesn't like my... Oh, I think I know what it might be. So let's do it like this. It might complain now. Yeah. So we have a few components which need to be explicitly cloned. Let's go over them. So node client KZG. Okay, now IDE sees this. So we can do this, clone, KZG, clone. Yeah, autocomplete sometimes is slower than to actually type it myself. Clone. Yeah, sometimes this is what you do in programming, just copy and paste over and over again. Okay.
Nazar, can I just clarify why it's required to clone it in this exact scenario?
Yes. So what we are doing is we are running a piece of code in a loop. And in Rust, there are kind of different types of values. There are dumb values, which is just a piece of memory. And that piece of memory can be copied implicitly. So like if you have a number, let's say number 10U8, that number is just a piece of memory. There is nothing special about it. There are no side effects. You can just copy it. It implements trait called copy in Rust. Sometimes values are less trivial. Let's say they're using heap allocation, so you need to actually reserve a substantial amount of memory, and that is something that Rust will not do implicitly for you. You need to explicitly call a function clone to actually do that. So clone usually means something more expensive. Not always. things like cloning the client will, in practice, due to atomic reference counting, not be very expensive. But generally, in those cases, you need to do explicit cloning. This is what we are doing, because the first time we will call this function, it will kind of consume those variables. And the next time it iterates, the value is gone already. So you kind of need to give a new instance of that value to the new function every time we iterate in this loop, such that the memory is not, like the instance is not gone. It's a very Rust specific thing. In many languages like JavaScript or Python, it will just be cloned by default implicitly, and that makes, in some sense, developer experience better or easier. But otherwise, okay, so plotting delay receiver. Plotting delay receiver. What are you? I see. I see. That might be a little bit problematic. What do we do about this? Basically, the problem is we are using, we have these receivers, which are the channels. But the problem is that these receivers will be gone after first call, and they are such that cannot be actually used more than once. So this is a bit of a problem. We will have to refactor this code. So we will have to do the following. Senders with capacity. With capacity is a good practice in Rust if you know how many elements you will have in it. And then we will have receivers. And since receivers will actually be sent into the senders will actually be sent in there. Okay, so let's okay, we can do actually reference. So we will create a mutex because we will need to access it from multiple places. You know what? We don't actually need that. Okay, different plan. We will create, we don't need these receivers. We will create receiver and sender in here, in the function itself, or in the future rather. What was it called? Sender and receiver. So we'll create a pair of sender and receiver in here, and we will only return once it succeeds. So we can recreate these channels as many times as we need, and we can just forget about senders which are from unsuccessful attempts. And then once we are successful, we'll return farm plus the sender. Let me close this one. So here now we have a farm and we have a sender. And then we will have many of these senders. Farm index. Okay. Farm index. Why do we have farm index here? Farm. Okay. Right, so just a tuple. So we can just return it somewhere in here. Then receiver, just like before, will be going without any cloning into our call here. And then this needs to change. And then the senders we were collecting in here, let me do like this. We will have to instead collect them after the fact. And that should still be okay. So we will have our senders. And there will be plotting delay sender and if this thing is successful, well, either, yeah, if it's an error, then right, we'll exit anyway. So into senders, we'll just push a sender. And then this should be okay. Yeah, this should still be okay. The only thing that's different is I think we might have a type somewhere specified explicitly. Expected result, found the sender. Let's see. I don't see why it wants that particular type. So let's just try to run it in the compiler. ID is not always correct. Right. Global mutex must be all right. So for our default, we'll need to clone it explicitly like this. Then for the plotting delay sender, it expects a result. Why does it expect a result? I think I know why. Because we have another return in here and we have a different type in there. So I guess the simpler way would be to do something like this and return our sender just in OK case because we don't care about it otherwise. So then we will have this thing just like before, and then we will have this thing in here, and now it should not complain as much. Let's see. Okay, what else? Right, this is no longer applicable. What else? Unstable, right. In unstable, we will have 3 values instead of 2, I think. Farms, push. Farm. Interesting. Yeah, for simplicity, let's just give it a explicit type. So farm index is it usize here? Box, then farm, something like this. Let's see. I think we are close. So in here we have these farms, right? It's something I forgot. We need to, I believe there is a length field on this one. And then, let's see. Okay, so it doesn't particularly 355 doesn't like what we are doing. Right, because we have another case in here that is not returning any kind of value. So we can just have a panic or to do or something like that, and it should compile, hopefully. Right. Or not. Okay, yeah. So in here, we will do continue. This is what we want, but we need to change a few things for the continue to actually yield a different result. So what we want to do specifically is we want to change the space pledged. So our disk farm, in this case, will have to become mutable. We will just modify it in place. And the allocated plotting space will have to go down. And we are giving a copy. This is copy type U64. We are giving it to the farmer for instantiation. We will just decrease it. And to make it faster, let's say we will decrease it by 10 gigabytes. So 10, numlock, 10 times, how do I fix this? Right, 1024, this is kilobytes, this is megabytes, and this will be in gigabytes. So we basically decrease the space despite configuration to something smaller. And we'll try it, hopefully not many times, before it actually succeeds. And if that is correct, and the final implementation will have to be a little bit more advanced, we will be able to actually not crash this time. So let's see. In the past, SpaceAkers was able to start and give the option to make space drive smaller in config, but now it doesn't start. Yeah. I don't think it was ever the case. I think it was always erroring if you don't have enough space. It might have shown you a configuration screen as is, but you will have to fill everything from scratch. So either way, it's more productive for you to just edit the config and not reconfigure everything from scratch. But this is something that we will fix with that issue. Okay, fingers crossed. Let's see. Okay, so let's see the logs. Oops. See, we were starting with about 100 gigabytes, and then it didn't succeed, and we tried again and again and again, and eventually it succeeded with about 43 gigabytes, which is, if you decrease it by 10 gigabytes every time, is about right for 50 gigabyte size. And now when Farmer finishes benchmarking, which is hopefully not very long, maybe like 30 seconds, we should be able to see that everything started, and then we show the sectors. We will have very few sectors accordingly to the configuration. So this is basically kind of approach you are taking. You identify when and what needs to happen. In practice, what we will need to do, we'll probably add a method on this enum that will give us true or false if the error is likely caused by the size issue. And if that is the case, we will actually query for the location directory. We will actually query how much space we have available. Then we will actually query the info of the farm. You can see the code for info in the monorepo. We don't have it here because we don't need it. Let me show you. In the farmer, commands, farm. The code is kind of the same, but slightly different. That might be a little bit misleading. The shape is the same, but the content is slightly different. So in here, let's see. I believe we did have a size check. Oh, right. We don't have it anymore. So in the past, there was an issue with Windows where we had to have a warning for the case when you start and you resize. That was causing performance issues. I will show you again later about the config. What I was telling. When we resized on Windows, it was killing performance. So we had to show a warning. So we were checking the space pledged. We can do that if we go to the. Oops, this is not what I wanted. I want in here and jump to the end. We have info function. Scrolling is faster. If you call not info, plotted sectors. Structure, single disk farm. Total sector count. all these properties. There should be a function here, collect summary. So if we call collect summary on the same path, we actually get, among other things, the info of the farm, and we can see the allocated space. So going back to where we will take the space that user wants with the config. We will take the space that a farm was previously, that is the actual space that was allocated successfully last time, and then we will compare how much more space we have against how much more free space we have on that disk. And if those are misaligned, then it is likely that we actually have a space problem, in which case we will be grading this, or like dialing back this number. And the edge case will be that we need to actually store that number. So we will want to update the config and store that smaller number. So and next time we run, we don't need to do this like iteration in a loop, failing and trying until we guess the correct number. The config is in .config space acres, and then there is a config JSON file, and this is where you can edit the size if you want. There is another issue in the repository about this particular challenge. That is reconfiguration support. Basically, ideally, what we would do is when you have a problem with the space or any other reason, then what we would do is we would just show you this screen, and it would highlight like, here is where you have a problem. Please correct and try again. There are some technical implementation challenges, why it's a little bit tricky to implement right now in the architecture we have, but this is kind of where we are going. Eventually, you'll be able to just edit this 100 to something like 30, and then try again, and on restart it will be successful without any retries. But this is kind of the approach you are taking. You need to intercept some information happening on the backend, maybe sending a warning to the front end like, hey, you wanted 100 gigabytes, but there was actually not enough space available on your disk, so we dial it back to this number. Feel free to update your configuration. This is probably the number you should be safe to put in. Yeah. I think that's about all we have time for today. Hopefully not the last time. Yeah, you can resize the thing in the UI, in the configuration in here. It's just when you have an error, you cannot do that, but otherwise you can, absolutely. All right, I think that's all I have for today. Thanks, everyone.
Thank you very much, Nazar. Yeah, that's a pretty neat solution to just gradually decrease the plot size. Yeah, I like it, and it's especially interesting to read and to find out more about the syntax that Rust uses, because it's completely different from all the languages that I used before. Yeah, thank you so much for the demo.
Yeah, sometimes it's not super intuitive. For example, we know that on XFS file system, sometimes if you try to decrease it a little bit, it actually doesn't succeed. So in practice, you need to like dial it even more down until it actually succeeds. So this is why you need like a few attempts. You cannot just do the calculation and be absolutely certain that you will succeed, because there are some properties outside of our control, let's say. That's why.
Yeah, I see. Right, I believe we still have a few minutes for any final questions. If there's anything, guys, you want to ask, or while we have Nazar, that's a perfect time.
Yeah, if you have any questions this time or next time, feel free to suggest them in the developers channel on Discord, and we may do something like this again with the topics you would like to see.
That'll be amazing. Yeah, it's always a huge pleasure to, having you over, Nazar. Yeah, once again, thank you so much for all the workshops that you did throughout the month. We really, really appreciate it.
Yeah, thank you.
Yeah, and in case you missed any of the previous workshops, they're all available on our YouTube account. If you go on the live, and it's all been streamed and recorded. So if you're curious on how to run and set up dev environment on Linux, or how to set up dev environment on Windows, it's all available for you guys. Yeah, and I've seen this comment which I wanted to address before we wrap up. So the person was saying that like I don't have enough knowledge to go and try addressing some of the issues. I would suggest to still kind of watch the workshops and try using some tools like ChatGPT because they are getting especially good for like explaining what this code does for you and helping you out with all the code changes that you have in mind. All right, I don't think we have any questions. Awesome. Thank you so much, everyone, for joining us today, and we'll see you next time.
See you guys.